How's it going, everybody? And welcome to our CCNP CCIE Enterprise Lab that we're going to be walking through. There's not going to be a lot of technical training in this particular little series that I'm doing that would be indicative of something you would see like an advanced technologies course. But what we are going to be doing is covering looking at the blueprint, and I've got a go ahead and actually save this real quick. 1 second. So I've got this lab that you can see in front of you on the screen, and really the goal, I've always had this goal of having a really big lab in front of me that I could basically cover just about any topic that's on the CCIE Enterprise and Infrastructure Lab exam blueprint, and do any variation of any technology that you could come up with. Now, to be honest with you, there's for any of you that are studying for your CCNP Enterprise certification, whether you're going for Encore and then an RC or SD-WAN, or you've already achieved your CCNP and you're working towards your CCIE, either way, the way that I look at it is if you've covered all the topics on the blueprint already, so you're 100%, you've got 100% coverage of the technologies. Now, for example, SD-Access, SD-WAN, maybe you can't cover them for whatever reason or whatever the case might be. SD-Access probably being the most difficult to actually lab because of the fact that it requires DNA center, ICE, you need some hardware in order to do the job. I don't know if the Catalyst 8000V would do it or not. I honestly don't know. But one way or another, you need something to work with in order to lab these technologies up. So in my opinion, the best way to do that is to come up with very large scale labs with a lot of options for you to work with. And that's how I studied for the CCIE when I was going for it, was build big labs and go through and what are all the different things that I could do in the lab to test my capabilities. Because at the end of the day, the lab itself, for those of you that may or may not be aware of this, is it's a measure of your technical understanding and your technical capabilities for implementation as fast as you possibly can. So back when I took the lab, back in 2015, which is just over 7 years ago for me. Actually, I just hit 7 years on the 19th, which actually surprised me. It's been 7 years. But nonetheless, back then it was 2 hours of troubleshooting, half an hour of diagnostics, and 5.5 hours of config. Now you could borrow a half hour from config and put it into diagnostics to give yourself an hour if you needed. You couldn't get the 5 tickets that you had. It would go through there. So I took the lab 3 times before I passed it. So it's not easy to do. And I would never consider myself better or a top dog. There's still some things that I struggle with in the routing and switching arena to this day. There's some things I'm just not very good at. QoS, not a strong suit. But very rarely do I ever actually work with it. But that's a whole other thing. And a really in-depth multicast. I don't deal with that a lot. So, but knowing that I'm weak in those areas, gives me all the more reason to, when I do have to do something with a customer, I know where I need to focus my time and effort, those areas. So my mentality, my logic has always been build a big lab, and then you can mix and match. You can get it working, right? And the key thing with CCIE lab, or gross, at least the route switch lab and the service provider lab, the 2 labs that I've taken, I took the SP lab once and I failed it. And I haven't gone back. It's been a little over, it's almost been 3 years. I took the lab, service provider lab, in 2019. So because I knew the time frame for the switchover was coming. So I took it because I thought it would be worth taking the time to do it. I'm glad I took it because then I know what, for the most part, what they're looking for. So um, the point being here is with certain labs, it's all about speed when you get to the lab. And the only way you get speed and you're fast on the command line is if you spend a lot of time on the command line configuring the things that are on the blueprint. And you only get comfortable with them and confident in your skills if you've put a lot of time and effort into playing with those technologies. That being said, if you don't put enough time and effort into it, it's going to show. And that's one of the reasons why I failed the SP lab was I hadn't put enough time and effort in, even though I thought I had. The lab exam is a good measure of your capabilities. You know, like I said, it's, you know, you don't go in there after you have just finished going through an advanced technologies course, or you just yesterday finished the last set of services that you need to cover, and then boom, you go prep for you go sit for the lab. That's not the appropriate time. You should be spending the time learning the technologies first. Give yourself that year or two, whatever that time frame might look like, and then give yourself another year or two to get really comfortable with the technologies that you're going to be implementing. You should be able to look at a topology like I have on my screen right now, and for the most part, in your mind's eye, be able to visualize what you're going to need to do and where. And that having that ability is a really key factor, because when you can do that, that's a really good it's a really good thing to have, because then you're going to know what you're going to need to do and where, how to configure it, what any gotchas that might come into play with it. So the purpose of having a lab this big is I'm going to walk you through, and I'm going to go ahead and pull this PDF. I wrote this lab. It took me about an hour and a half to write it. And the point of this lab is to walk you guys through some of the different options and capabilities that you might be tasked with configuring. Now, I wrote this lab, and there's a lot going on to it, and essentially this series of videos, I don't know how many videos it's going to be, is going to be the video solution. So there's not going to be a companion to there's not going to be an answer sheet for the PDF. It's literally going to be, can you configure all the things that are here and do them the way that they're expected to be configured and get them working. So let me just kind of walk you through at a high level what the expectation would be. So, and I didn't assign point values to anything either. But as you can see, there's quite a few items in here where it's basic networking and stuff like that. But this is something sort of similar. A lot has been removed intentionally, because this video is not necessarily to say, hey, this is what you could expect when you're in the lab, because the UI is going to be completely different. You get two monitors when you go sit for the lab now versus the one that I dealt with. But what you're basically going to do is you're going to get chunks or blocks of tasks that you're going to be required to configure. And it's an all or nothing type of scenario. So in other words, the way that I've got Catalyst distribution and access, which is going to be this little block of devices right here, what you end up getting is 10 specific things that you have to configure. And the goal would be to go in and configure those things, and you must configure all tasks in a particular block of configuration, not only correctly, but not violating any of the exam rules. So, for example, there's going to be global rules that apply to the exam as a whole. At least this is how it was when I took the exam. There were rules like, when you're creating an access list, a prefix list, or a route map, don't use underscores, use dashes. Okay, I'm not violating a rule there, because that's just it's a nomenclature thing. So and I accidentally did do that because I was used to using underscores in production. That was something I always did. It's route RM underscore whatever it is I'm going to be doing, and I do that on purpose because then it gives me, a flow to what I'm trying to do. So you'd have to go through and configure your tasks not violating any global rules, like what I just mentioned. Do not change the username or password to any of the devices, stuff like that. But there were also question-specific rules or exceptions. So, for example, when I took the SP lab, there was a rule on one of the tasks that said there's a global rule that said you cannot configure any static routes or create tunnels to route around existing routing problems. So in other words, jump over the problem to get to where you got to go. There was one specific rule that said you are allowed to create a static route for this particular scenario. I'm not going to give you any more details than that. If you know what I'm talking about, great. And if I see comments about specifically what that rule is tied to, and you're like, oh, it's to this, I'm going to go in and delete your comment. So don't even bother commenting that you know what I'm talking about. Just, if you know, you know. So in situations like that, so you're going to have exam level rules and expectations, and you're going to have question level expectations and gotchas. So let's say, for example, that the exam, when I took it, the configuration section was worth, so troubleshoot was 10 points. Diagnostic, I think, was 6. I believe. No, troubleshooting was 20. Yeah, troubleshooting was 20. Diagnostics was 6. Because you could get then, I think, 74 points, if I remember correctly. So you might have a section where this block of 10, you might get a point per task, right? And if, let's say, for example, you didn't make sure to set the secondary route on switch 21 and switch 22 as a secondary for each other for the different VLANs, well, there's a script that goes in and checks the exam to make sure you did what you said you were supposed to do, right? And if it went in there and it was looking for a specific output and it didn't find the secondary command, or it didn't see 2 entries in global config or the outputs, you would not get points. You would have missed this line item in the tasks, and you wouldn't get any points for that section. So you lose 10 points, you're done. It's like you lose that many points or you're not going to pass the test. Simple as that. So that's essentially what you were required to do. Now, I've written this in a similar way to where you're going to have a configuration block, and it's your job to implement all of the things that this configuration block requires of you to get it to work to a certain way. The one thing that you really need to understand when it comes to any configuration-based labs that Cisco puts out, like CCIE, is, number one, this not how you would do it in the real world. And actually what's funny is it's not best practice is the best way to put it. So the one thing that I've learned over time, and especially in the last, I'd say, 3 or 4 years, but I've known this longer than that, but it's become more and more prevalent over the last 3 or 4 years, is more often than not, the longer I do networking, the less I do best practice. Like, there's obvious architecture things that we use that are best practice, whether it's a cabling thing or, for the most part, we're doing best practice up to this point. But depending on the deployment and what's needed, there might be a bug fix, there could be some sort of specific issue that we've run into where we've got to say, you know what? Best practice is not going to work here, and this is what we have to do in order to bypass this. It could be any number of reasons why, and that's why they call it de facto standards or best practice. Best practice doesn't mean always implement. It means that in most common scenarios, as long as the majority of things will work out, you can implement something in this particular way. And this is what the industry typically does. So that's why they refer to it as best practice. But in regards to the real world, I have done things numerous times that I would never consider best practice, and I oftentimes will tell customers, I normally wouldn't do it this way, but in this particular case, in order to meet the needs of the customer, I'm doing it via this way so that we get the job done. And they understand that. The one thing that's interesting about networking is just about every network that I've ever worked in, there's a lot of similarities, a lot of overlap. You're going to see a lot of very similar technologies, whether it's layer 2 or layer 3 capabilities implemented, but there's always something unique to the environment, whether it's a naming convention or an addressing space or whatever. There's always something unique that I have to work with in order to get something done. But every network is a snowflake. Even if they're cabled similar or the architecture similar between two different networks, no two networks are the same. So the one thing that when I was writing this and I was also building this lab, building the lab was the first thing that came, and I wanted to build something that could mimic a very large scale enterprise network. Now obviously with the sheer size of the lab, it's designed to have a lot going on. And if anybody's wondering how I built this, some of you might remember that Dell R810 server that I bought several months ago. I think it was at the beginning of this year, actually. And I bought the server. It's got like 96 gigahertz of compute, 256 gigs of RAM. It's kind of a beast. Well, I loaded ESXi up on it the first time I worked on it. And then my intention was to deploy Eve to it and then deploy a bunch of Nexus switches because that's really what I work on a lot. But the problem I ran into was no matter how many vCPUs or how much RAM I gave to an Eve instance, an Eve OVA that I would deploy, I wouldn't be able to get any more than 6, 7, 8 Nexus 9Ks deployed. And it really irritated me because I was like, damn it, this should be easier to work with. So it wasn't until this past week when, and I don't even know what triggered the thought. It's like, what happens if I was to install Eve directly to the server? Because I've gone through and I've had, 30 CSR 1000 Vs running on this box. I've had, a dozen Nexus 9Ks deployed and to do some weird routing that I had to do for a customer, and that it was like a champ. It worked great. I was like, well, what the hell? So I decided to rebuild it. I blew away everything that was already on the server. As a matter of fact, I deployed. I didn't. Anything that was sitting on shared storage is still there. So technically speaking, I can recover anything that I want. But what I decided to do was let's install it bare metal. So I looked it up, deployed it bare metal, and right now I have all of these devices running. They're currently operational right now. If I was to pull up this guy right here, you're going to see that I think switch 22 might have been open twice. You can see that I have all these devices opened. The cool thing about it is if I go over here to status, the status pulled up, I have 48 QEMU nodes running. I'm using 13% of the 13 to 15% CPU and a little under 20% memory. And I was like, what? Now, mind you, there's a lot of Nexus 9Ks that I don't have turned on at the moment because I just haven't gotten that far, and that's going to be one of the last things that I do. And I'll talk about that here in just a minute. But I wanted something big that I could do a lot with and write a lab that would be that would allow me to cover all the different technologies in the blueprint for enterprise, and also would give me the ability of building out both an enterprise-based environment plus service provider plus MPLS, and do the overlay routing with DMVPN and all that cool stuff that goes along with it, and then be able to do end-to-end connectivity. I've built this lab probably a dozen times in virtual machines inside of Eve, and on that server, I'd get more than 10, 15 devices powered on, and I'd run into CPU. And it would be like, okay, that's not going to work. So I'd give it more resources. As a matter of fact, I deployed one VM. I gave it every resource you could possibly give it, minus a little bit for just the server to run. 22 or 23, I think I got to, and it started to crap out of me. I got to 70, 80% CPU. It just wasn't doing the job. So, long story short, running it bare metal seems to be the better way of doing it. And this has been up for about a day, this lab. I started building it out. Actually, it's been up 2 days now. I started building it the other day. If you check the description, there will be a Google Drive link where this topology and the lab will be available. I will be providing on a per block of configuration all of the device configs for it. So the solutions will be available in the Google Drive, which you guys can access for free. I'm not going to make anybody become a member or do anything like that. But because one of the things that I'm planning on doing is actually redoing the way that I do things, and I'm looking at putting together another training site where I'll take everything that I do, usually on YouTube, and I'll throw it up on a training site that will allow me to be way more flexible with how I do things. And I'll turn YouTube into a little bit of a different way of doing stuff. I'll put stuff like this still out, but I want to do stuff that's more relevant and not super technical, because the YouTube demographics really don't play well when you get super specific. So you might only get 100, 150, 200 views on a video, and to be honest with you, as much as I want a bigger impact than what I'm getting, because I want more people to be able to take advantage of the material that I'm creating, because I do feel like I put in a bunch of effort and time into the material, and I usually don't get a lot of people to watch it. That's not your fault. It's not YouTube viewership or the subscriber problem. It's more or less the content itself. Like, there's not a very large demographic of people looking for that specific content. So, and that's fine. It's what I choose to cover. So I figure put in a training channel or a training site, and then I can churn YouTube content a little bit differently and go back to figure out what it is I'm going to do with YouTube from there on out. Probably put some of the stuff that goes up on the training site on YouTube as like, hey, if you want to see this, like, to put some previews out there for you guys, and then have you guys then come over to the training site. But this will allow me to be more flexible with how I do stuff. So let me go ahead and give you guys kind of a walkthrough and tour of the topology, because this will give you somewhat of a real world feel for what you could potentially see in the CCIE lab. Obviously, I haven't taken the Enterprise Infrastructure Lab, so I have no idea how close or far away this is. And you might also notice that there's no SD-WAN here. There's no SD-WAN at all because I've already covered SD-WAN in a different series, and I covered it for the version of code that the CCIE lab is going to be testing you on, which is 18.4. So I've covered just about everything you might get tested on that I've been able to find or work with. So I feel like no need to bring that up here again. But I'm probably going to cover SD-WAN again because I actually work with it in my day job. But no, nevertheless, what you're going to end up having here in this topology is one big HQ site, right? And inside this HQ site, we have a core network. Actually, let me go ahead and move that a little bit more center. You got the core network where you've got a routed core, and the beauty of this is it's being Eve image. I'll be actually able to swap out different pieces of equipment. So if I wanted to say I'm not happy with the CSRs, or let's say I want to get away from the CSRs and I want to go to Nexus because I want to be able to go from, say, 10 gig to 100 gig in my backbone, that would give me the flexibility of doing that, because real Nexus switches would support 100 gig on their interfaces. So that's one of those things that you could also do. But that's an option that we'll cover down the road. Now, operationally speaking, when we talk about how this connectivity has come into play, we have a couple different end user blocks. So we have a Catalyst distribution and access. So traditional layer 2, layer 3 networking that you guys are already familiar with will be down here on Catalyst iOS. And then I have another topology over here where it's Nexus distribution, Catalyst access, so that you guys will get exposure to Nexus. Because one of the common things that I see day in and day out in my customer environments is a combination of both Nexus and Catalyst, and this exact same design. So we're going to be taking a look at how that would come into play in that scenario. Then up at the top here, I have a data center, and which there's no Nexus 3000V that I know of, which would be more of your end user connections or your server connections. So what I ended up doing was I wanted to cover back-to-back VPC, because I do have a few customers that actually have it deployed, And there are some use cases for it, so I wanted to cover it so that we'd see exactly how it would get deployed in this particular scenario. So it's taking what we have right here and expanding it up here and doing Catalyst in the access layer to get that connectivity in play. So that'll be just another thing that we go through and do a back-to-back VPC and get that working. I don't see them very often, but to me, it's something worth covering. Now over here on the left-hand side, we have our VxLAN environment, where I'm actually going to be deploying VxLAN between these three Nexus 9Ks that are right here, and they'll connect to the core routers via direct wiring. So we'll have servers that we'll be able to connect into and work with. So we'll be able to telnet into these servers and stuff like that. I'm doing VxLAN, and I'm going to actually come back over here and talk a little bit about that and the why behind VxLAN. And the reason why is SD-Access is something that is deployed with DNA Center, and the problem that I have right now is I'm not sure if and when DNA Center, there's talk of it coming out either the end of this year, end of 2022, and sometime first or second quarter of 2023 as a virtual machine. And that's great and all, but the problem is I don't know if the Catalyst 8000V will be compatible with it. So the way that SD-Access works is you have an overlay network built on top of an underlay network. The underlay network uses IS to IS for communication, and then you run VxLAN and Lisp on the top of it so that you can use Lisp for your workload mobility, devices moving back and forth, and you use VxLAN for the data plane encapsulation. Well, the closest thing I can come up with that's going to mimic that would be VxLAN, where VxLAN uses BGP for its control plane and not Lisp. And there are some similar devices that, terminology-wise, would still come into play. You do have the spine. You have your edge node and you have your border node. Your edge node, in this case, would connect down to your end users. Your border node, which would connect up to the rest of the network. So there'd be the difference between your SD-Access environment and the rest of your corporate network. So there are similarities in the way that it gets rolled out, and it does allow layer 2 extension through VxLAN. So you're basically tunneling over a layer 3 backbone. We're going to be doing the exact same thing here, except we won't be using a controller. So we're not going to be using something like DCNM to Data Center Network Manager or Nexus Dashboard Fabric Controller, NDFC. Actually, it's technically Nexus Dashboard with the Fabric Controller app installed on it. I've done both. So that's something else that I'll be talking about and deploying at some point in the future. But for right now, I'm not going to be deploying it for right now because other things are taking precedence over it. But that's essentially what this will come into be, is it'll be my pseudo SD-Access environment. No wireless here. I'm not going to be dealing with any wireless, but I do have a 2504 controller in my basement that's powered on and configured, and I just bought 3 3702 access points the other day so that I can, once I get done with Encore, I actually do have the interest in learning wireless, so I'll be doing the CCNP wireless here probably soon as well. And then over here on the right, go ahead and get out of the way again to make it look big. We've got a couple of service providers. And actually, let me go stop over here. So we have our Internet Edge and we have our WAN Edge. The Internet Edge obviously is firewalled, and we've got some Palo Altos. And the reason why I went with Palo Alto and not ASA or FTD is because I think I only have 1 or 2 customers that deploy FTD or ASA. Everybody else is Palo. And more often than not, it's Panorama Palo. So what I'm going to be doing is deploying Palos, and they're actually right here. They're up and running, good to go. We're going to be walking through deploying Palos on the edge and getting them up and running, because they're the firewall platform I see the most. Not to say that ASAs and FTDs aren't out there, but for my case, I don't see that platform much anymore. If I do see anything, it'll be FTD hardware running ASA code, or FTD hardware running FTD code. So with that being said, that's basically where I see things going. Now, the other side, in the WAN here, we have, and we're going to eventually do active passive, so we'll have failover between the devices, which is why I have it set up the way that I do, and I'll walk you through that once we get to the internet edge and what that's going to look like. Now, on the WAN edge, I have a couple of routers, and these routers connect off to the internet, and they also connect off to the MPLS environment. So you and I are going to be building 3 different service provider BGP setup internet providers to cover BGP in a variety of different ways. And I'm doing this so that when we go through and get this configuration in play, you'll have a pretty solid understanding how BGP works under the hood and getting routing from the spokes that are over here to the hubs that are over here. Now, I have connectivity to the internet on the WAN as well to provide us connectivity into our overlay, which is going to be DMVPN. So I'm going to be deploying DMVPN in a pretty large scale deployment. The NARCI exam calls out 1 spoke and a couple of hosts. I believe the CCIE lab, actually, let me just double check that real quick. So here, if I go to certifications, I look at CCIE Enterprise Infrastructure, and I look at the exam topics for the lab. And I look at, which one is it? Right here. It says troubleshoot DMVPN phase 3 with dual hub. So we're going to be taking a look at dual hubs and how that would come into play. Next up, resolution protocol, NHRP, IPsec IP2. But when they say IP2, that's FlexVPN, because IP2 uses FlexVPN. So it says troubleshoot DMVPN, so I have to assume DMVPN is going to be in there in phase 3. So they want all the best and the best of the best when it comes to DMVPN and dual hub for redundancy. But at the same point in time, they've got, identify use cases for FlexVPN. So this particular part, to me, would be something you would see in the design section, and how you would design FlexVPN to either replace DMVPN or to be a migration to FlexVPN down the road. It might be enhanced security through certificates or pre-shared keys, because then you can IP2 does things differently than IP1 does and stuff like that. So you have IP2 has a lot more capabilities than IP1 did, and you can mix and match your authentication mechanism. One side could be pre-shared key, the other side could be certificate. So that's just one example of how that would come into play. But these are going to be what we cover. In the lab that I wrote, DMVPN. Lab 2 might have FlexVPN. I don't know yet. It depends on my mood. So with that being said, we'll take a look at that. There's going to be 2 hubs. We'll have 4 spokes, so it's a pretty big deployment. And then over here in the MPLS, we're going to go through, and before I jump any further, you're going to notice that I've got XR boxes in here as well as Nexus, because Nexus supports dynamic routing with BGP. We're going to be taking a look at deploying it with BGP and how that comes into play and how you would work with Nexus in this type of an environment, and that as XR, iOS XR, and how that would come into play. So my goal is to try to bridge some of the service provider technologies and topics into what I'm doing here. So this topology here you may see used as a deep dive into all the different routing protocols, because the way that I would, if I was going to build CCIE level training, I would incorporate, I do enterprise infrastructure as the main focus, because that's going to be one of the more popular CCIEs to go after. But I would also bring in a lot of service provider technologies, because like XR, because you're going to need to know about them anyway. And then as byproduct of that, I would also look at doing something like Nexus, because it's another popular platform. So it's more data center, but there's still quite a few customers I work with where they have no Catalyst at all. It's all Nexus, and they do that for a variety of reasons. I mean, there's not no Catalyst. There's a little bit of Catalyst, but the majority of the core and distribution is Nexus. So, some things to be aware of. So, that's that. Let me go ahead and jump back over here. So we have our service provider here, MPLS, where we will be deploying a full MPLS VPN and getting connectivity up and running to some of these remote sites. So some of our spokes will have MPLS access to them, and we'll be able to route traffic over via MPLS, and then also have like DMVPN. So we'll have like point-to-point connectivity as our primary, and then tunnel VPN as a backup, or the other way around, depending on the scenario. And then lastly, you see these two data centers here. We have Colo DC1 and Colo DC2. This is actually a very common thing for me to see, where you might have on-prem VxLAN deployed, and then you want to do things like replication to your Colo. And you might be moving workloads from on-prem to off-prem, to a local cloud provider or something like that. And the goal would be to set up all three fabrics, have VxLAN running on them, and then have basically set up VxLAN EVPN multi-site to connect what you see here to the colos to do things like replication and stuff like that. So these are real world scenarios that I've been thinking about, like, okay, how would I demo that? How would I put that into a lab? And this is what I basically have come up with. And I know the question is going to be, well, couldn't you replace Palo with FTD? And couldn't you add in SD-WAN? I could, yes. Nothing says I can't. At least in the first lab that I built, I wanted it to be mainly route switch focused. So that's what we're going to be doing. So with that being said, ladies and gentlemen, if you have any questions, please leave a comment in the comment section below. The PDF for the lab that we're going to be walking through here starting in the next video, we're going to be diving into and getting that working. And if you have any, if you're not sure on how this would work or any questions on it, leave a comment down below. I'll be happy to answer it. Please like, share, and subscribe, and I'll catch all of you guys in the next video. Have a good one, guys.